Welcome back. This is Karen Timberlake's Basic Chemistry, Chapter 7.2 on molar mass. So if you were to look at the periodic table, you will see two main numbers that give you tons of information. One is the atomic number, and the atomic number is sequential, each giving you the number of protons in that specific element. The other is the mass number, and the mass number is the combined number of protons and neutrons in that element. It's a weighted average, so there's usually a decimal point that's involved, but you can make a round it up in some way and find out how many protons and neutrons that is. If you were to, instead of use AMUs, which is the average between a proton and a neutron, because they're so close to each other in weight, that an atomic mass unit is really just the average between a proton and a neutron. And so that number that you see in the mass number is in AMUs. If you take it in grams, okay, basically just make a jump and say, instead of 12.01 AMUs in a carbon atom, what if I were to have 12.01 grams of carbon? We'll see that in 12.01 of carbon, the same number that you can get in the mass number, you will have 1 mole of carbon. Okay. Otherwise, that's Avogadro's number of 6.022 times 10 to the 23rd atoms. So in this case, you're going to, the molar mass of a compound is simply going to be that compound's formula multiplied by each one of the atoms. So if there are, say, 2 hydrogens in the compound, like water, H2O, I take the atomic mass of hydrogen twice, I add it to the atomic mass of oxygen, and then that combined mass is 1 mole of the whole compound. And that's what we're going to do today. The molar mass is the mass of 1 mole of an element. That was easier. All you do is look at the atomic mass under the element on the periodic table, or it's the mass of 1 mole of a whole compound, which is simply each of the elements in that compound added together, the atomic mass of each one added together, and the total would be the molar mass of the compound. And instead of expressing it in atomic mass units, you're going to express it in grams, which is easy to measure. So here is an example. Silver, on the periodic table, its mass number is 107.9. So to have 1 mole of silver would require 107.9 grams. Carbon, 12.01. In 1 mole of carbon, there are 12.01 grams. And sulfur, 32.07 grams in 1 mole of sulfur. So to review, when you have a compound, you simply take all of the atomic mass of each element within the compound. And if there is more than one in that compound, you have to double it or triple it or whatever it says. So for instance, if you were to have the element calcium chloride, which is CaCl2, you will take 1 calcium atom. So you go to the periodic table, you find that the calcium atom is 40.08 grams per every mole. And in chlorine, you would need 2 of them since there's 2 in the formula. So there's 35.45 each. So you double that to 70 and you add them together, and your molar mass is simply going to be the sum of all of the atoms in that compound. So here is potassium phosphate, K3PO4. That means you go to the periodic table for potassium, it's 39.10. You multiply it by 3 because there are 3 potassiums. That gives you a amount for potassium. Then in phosphate's made up of phosphorus and oxygen. There's 1 phosphorus for the whole molecule, so find out it. You don't have to multiply it. That's just the same. And there are 4 oxygens, so 4 times 16, 64, then you add them together. So because each element weighs a different amount, you're going to have a different amount in grams for 1 mole of every particular substance. So in the case of, say, sulfur, these are all 1 molar quantities. So here's sugar, here's potassium dichromate, here's table salt, here's iron, here's sulfur. They all have a different amount. Some, of course, are going to be gaseous, some are liquid. So they're going to look different in terms of amount, but they'll each have the same amount of molecules. Remember, they're each going to have, if you've got 1 mole, you've got 6.22 times 10 to the 23rd molecules. And if it's an element, you have 6.022 times 10 to the 23rd atoms. So I hope this helps you. It's not very difficult. It's a pretty easy concept, and I think you can get this. Look back if you need to review it at all.